Hello viewers, welcome to add-on. In this question, we are asked to minimize the following expression using K-map. So this is a K-map of 4 variables because 4 variables are given here, which are P, Q, R and S. Okay, and these are the main terms which are given to us, and these are the don't care terms. So let us start with the K-map. So first of all, we will draw the K-map. So this is a 4 variable K-map. So what we are gonna do, we will be using two variable PQ to represent the row number, and we will be using two variable R and S to represent the column number. Now this PQ, R and S, these are all 1 bit variable. That means they are only having value of 0 or 1. So if we combine P and Q, so they become a 2 bit variable combined. So then they can have a value of 0 0 0 1 1 0 1 1, and the same goes for R and S. Okay, but these are the values in binary, but in the K map we will be using only gray code. Now what do you mean by gray code? So for 0 0 in binary, by gray code we will write the first bit at first, and after that we will XOR get these two adjacent bits to write our second bit. So 0 XOR 0, it will be equivalent to 0. Now 0 1, first bit is 0. Now XOR get these two adjacent bits, so 0 XOR 1, it will be 1. Now for 1 0, first bit is 1. Now 1 XOR 0, it will be 1. And for 1 1, first bit is 1, and 1 XOR 1, it will be equivalent to 0. So this is our equivalent gray code. So 0 0 0 1 1 1 1 0. So let us write like this, and these are our columns. Okay, so these are also 0 0 0 1 1 1 1 0. And now we will use the cell number to determine which are the main terms given here, because this 0 1 5 9, these are particularly the cell numbers of the KMF which are given to us. So how do we get the cell number? Let us consider this is a cell. So for this cell number, we have to combine the row value and the column value. So for this cell number, the row value is 0 0 and the column value is 0 0. So this cell has a value of 0. So this is 0. And now for this cell 0 0 0 1, it has a value of 1. Similarly this has a value of 3. This has a value of 2. This has a value of 4. This has a value of 5. This has a value of 7, and this has a value of 6. And now for this has a value of 8. This has a value of 9. This has a value of 11. This has a value of 10. This cell has a value of 12. This cell has 13. This cell has 15. This cell has 14. Okay, and now this cell numbers which are specified in the mean terms, okay, we will write 1 in the cell numbers which are specified. So for 0 1 5 9 13 14 15, we will write 1. So 0 1, for cell number 1 it is 1, for 5 it is 1, for 9 it is 1, for 13 it is 1. Okay, 0 1 5 9 0 1 5 9 13, it is 1. Then 14 is here, 14 it is 1. Then for 15 it is 1. Okay, so I guess I've written all the codes: 0 1 5 9 13 14 15, 0 1 5 9 13 14 15. And the don't care terms are 3 4 7 10 11. So we will write the don't care terms by either cross or D. Okay, so the terms are 3 4 7 10 11. And the cells which are left out, like this 2 6 and 8, we will write just 0 here. Okay, so next up is the grouping. So we will do the group in such a manner, we will combine two or more adjacent ones which are present side by side. Like these two ones are present side by side, we will making groups like this by placing adjacent ones in a particular group. Now this group size will vary in the order of 2 to the power n, where n is equal to 0 1 2. So 2 to the power n can be either 0, either 2, either 4. So we will be making group of either sorry, it will be 1. So we will be making group of either only 1 bit, or 2 ones, or 4 ones, or 8 ones, or 16, like this. Okay, and one thing we need to see that, for example, this one are placed side by side. So if we put them in a group, we will be getting a group of 2 ones. But if 1 1 and below them two don't care terms are given, we will take a combined group of this. So we will make a group of 4. Okay, so we will be only including the don't care terms when we are saying that it will increase the group size. Okay, so this is our principal idea in this case. So let us make the group now. So the first group, as we can see, this line, in this vertical line, all the cells are 1, and this vertical line, this is 1, and these are don't care term. So we can make a group of this cell. So this is one particular group. Okay, so this is one particular group. Now for this particular group, the value of P and Q, as we can see, they are all changing, right? The value of P and Q are all changing. So the variables whose values are changing, we will discard those variables. We will be only keeping those variables whose value are fixed. Like for the row wise, all the values are changing. But for the column wise, the value of R is changing from 0 to 1. But the value of S is fixed. Okay. So we will write S. Okay. For this group. Right. And now for the next group, as we can see, if we make, if we take this group, okay, 0 1 1 1 and this group, we can see the value of P here is fixed at 0, but the value of Q is changing from 0 to 1. So the value of P variable is fixed at 0. Now as the value is 0, so we will represent it by P bar. And for the column wise, the value of R is fixed at 0, the value of S is changed from 0 to 1. So we will write P bar R bar. And now we will see if any ones are left out. So this one is left out, we will also include it in a group. So we will include it in a group. So we will get here the value of P is fixed at 1 and the value of Q is changing. So as P is fixed at 1, we will write P, and here the value of R is fixed at 1, the value of S is changing from 1 to 0, so we will write only R. Okay, so this is our finalized Boolean expression because all the ones are included in a group. Okay, so this is our finalized Boolean expression. And if you want to make the logic gate diagram, it is quite simple. Let us erase this portion here. Okay, so if you want to make the logic gate diagram, we are taking P, R and S as inputs. So the first term is S, so let us connect it to a wire, and we have to AND get P bar and R bar. So this inverter give us P bar, this inverter give us R bar, and if they are AND gated together, we will get P bar R bar. And the next term is PR, so this P and this R, if they are AND gated together, we will get PR. And now all of these terms needs to be added, so we will pass it through a 3 input OR gate. Okay, this is a 3 input OR gate, so the output will be S plus P bar R bar plus PR. So this is our required logic expression. Okay, thank you.